Okay, this is 3.5a of geometry. So we have a parallel postulate, postulate 3.2. It says if we have a line and we have a point, there's only one line that can go through that point so that the lines are parallel. We also have the triangle angle sum theorem, which says that the angles inside of a triangle add up to 180 degrees. An auxiliary line is a line that we draw and add into a picture. So we add it to the diagram so that we can reference the angles. So I'll go through this proof if you're curious how it works. If not, you won't be tested on it. So we draw in the line PR, and I'm allowed to do that drawing it parallel to AC, the line down here. And I can do that because of the parallel postulate. Angle PBC, that guy right there, and angle 3 are supplementary. So those guys are supplementary. They add up to 180. And that's because the definition of supplementary. Or linear pair, sorry. And then I'm allowed to say that the measure of angle PBC plus the measure of angle 3 is 180. That's by the definition of supplementary angles. Then I'm allowed to say that the angle PBC is made up of angle 1 and 2. So I can say the measure of angle PBC is equal to the measure of angle 1 plus the measure of angle 2 by the angle addition postulate. Then I'm allowed to say that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 180. That was combining these two right there. I plugged in for PBC. I know that angle 1 is congruent to angle A. Remember, angle A is over here. And angle 3 is congruent to angle C because that's alternate interior angles, because I know that PR is parallel to AC. And since I know that the measure of angle 1 is equal to the measure of angle A, since they're congruent, and I know that the measure of angle 3 is equal to the measure of angle C, since they're congruent, I'm allowed to say that the measure of angle A plus the measure of angle 2 plus the measure of angle C is equal to 180. Okay, here's a problem for us. Looking at this picture over here, I need to find the measure of the variables. So I'm going to redraw ABD down here. A, B, D. So I have 59, 43, and X. I know that angles inside of a triangle need to add up to 180. So 59 plus 43 plus X needs to equal 180. 180. 59 plus 43 is 102. Oops. And when I subtract 102 from both sides, I get X is equal to 78. Okay, now if I look at angle or triangle BDC, I have 49, Y, and Z. Well, I know they add up to 180, but since I have two variables, I can't do anything. I won't be able to solve for Y and for Z at the same time. But if I look at this whole triangle, A, B, C, C is Z, A is 59, oops. And the two angles that make up B are 43 and 49. 43 plus 49 gives me 92. So I know this is 92. Now I only have one variable, because that's a Z. 92 plus 59 plus Z equals 180. 92 plus 59 gives me 151 plus Z equals 180. And I subtract 151 from both sides, and I get Z is equal to 29. Now I can go back to my middle triangle, and instead of z, I have 29. So now I have 49 plus 29 plus y equals 180. 49 plus 29 gives me 78. I subtract 78 from both sides, and I get y equals 102. And there's your homework.